Hello students, welcome back. In section 2, we went through some very important classes of problems, graph problems, but graphs of not the original function, but graphs of the derivative function. Now let's discuss some calculation problems associated to increasing, decreasing, and concavity. First, absolute extrema. That is absolute maximum versus absolute minimum, given interval, given closed interval, and don't pay attention to the trigonometry part. Next, local extrema, local maximum, local minimum. Which is easier? Absolute maximum, absolute minimum are easier. So I'm going to do that first, even though in our textbook it is the other way around. In the textbook, we do local maximum minimum before absolute maximum minimum, even though that's much harder. Okay, let's determine absolute extrema of the given function. Okay, how do we do that? We have algebraic expression of the function. So the very first thing you should do is to plot it. X cubed plus x squared minus x from -1 to +1. See, we have this graph. X equal to -1, we get this. X equal to +1, we get that. And somewhere here, looks like I'm going to get absolute minimum. Okay, all right. These two, endpoint at x equals to -1, left-hand side endpoint. Here, endpoint at x equals to +1. We can just plug in and do my computation. What are those? F of -1 is -1 cubed plus -1 squared minus of -1, and that's equal to what? This is -1, +1, negative, that's +1. What about f of just 1? That's going to be even easier. 1 cubed plus 1 squared minus 1. So that 2 is 1. Okay, so we have we can write like this. We have the absolute maximum y equals to 1 at x equal to -1 and also at x equals 1. That's because these two happen to be the same maximum there. If one of them had been a little bit bigger, then you have to discard smaller one and take only the larger one because you're looking for absolute, the biggest maximum. Now, how about the absolute minimum down here? That's going to be a bit of a challenge. But then again, you see, absolute minimum is taking place at horizontal tangent here. Do you see? Horizontal tangents, how do you find it? You have to take the derivative and set it equal to 0 to find it. And there may be other critical points outside -1 to +1, but I don't care any of those. I just want something right here. So how do I do that? Let's just take the derivative. 3x squared plus 2x minus 1 and set it equal to 0 because I want horizontal tangent, so derivative equal to 0. And solving this equation using some algebraic method looks like that's not too bad because this is a quadratic equation. Looks like you get 3x plus 1, x minus 1. No, the other way around. 3x minus 1, x plus 1 equal to 0. Yes. So x equals 1/3 from the first factor, or x equals -1 from the second factor. Which one do you think is necessary one? Look at the picture. Graphs are important. Clearly, x equals to 1/3 is the one you're looking for, right? Right here. So we want absolute minimum at x equals 1/3. And then that is, let's see, plugging everything in. Okay, that's going to be a bit of a dirty computation. Is that it? Minus of 1/3. That's going to be the absolute minimum. What is this quantity? I cannot do this with my mental math. I'll just put everything into the calculator. Negative 5/27. By the way, what is the decimal value? About negative 1.85 something. Okay, negative 0.2 is here. Yeah, that's about right. That's how you can do it. Look at the picture first, and then endpoints are always candidates. Plug in and do your computation. Take the derivative, set it equal to 0 for additional candidates. Again, calculate. The biggest is the absolute maximum. The smallest is the absolute minimum. It can be tedious, but with the help of calculator, within time you can do it. Here's a solution. Take the derivative, set it equal to 0, and then x equals 1/3 is the one you're looking for. Endpoint, always consider those, and then this one you consider. But then again, doing all those computations without the guidance of the graph can be very, very difficult thing to do. People used to do this in 1920s, 30s, 40s, but nobody does it like that these days. They always begin with graph. Enough time for the next problem? Okay, all right. Here's another problem. Log of 8x squared minus x to the 4th power. And let's find out the absolute maximum, absolute minimum in the interval 1 to e. Again, what's the first thing you should do? Plot it. I'm using Mathematica here, but you can use Desmos graphing calculator or anything, any calculation tool. Well, that's what I got. Plug in x equals to 1, we get this value. I don't know exactly how large it is, but I don't care. I can clearly see that this is neither maximum nor minimum. And around here I have local maximum, also absolute maximum. And right there at the endpoint I have absolute minimum. Do you see it? So we have to have absolute minimum, f of e, which is log of 8 e squared minus e to the 4th power, which is, oh, I have no idea what that is. I have to punch in the calculator. As a matter of fact, this expression by itself is that squared minus e to the 4th power. 1.5 something. This is the absolute minimum. Let's see, this is 1.6 here, so 1.507. Yeah, that sounds right. That's about right. Okay, we got absolute minimum. Now, how about absolute maximum? It's got to be somewhere here. We need horizontal tangent there, so we are going to take the derivative and set it equal to 0. Are you with me? So let's take the derivative of this. Log of something. So what's the derivative of a log function? Derivative of log of x is 1 over x. We have something complicated, so whatever heck that is inside, it goes to denominator. After all, the chain rule says nothing changes inside. And then multiply the derivative of the inside by chain rule. 16x minus 4x cubed. And we have to set this one equal to 0. And let's do one more simplification before that. 16x minus 4x cubed over this 8x squared minus 4x to the 4th power. and then setting this one equal to 0. Don't be intimidated. You have a fraction equal to 0 simply means the numerator is equal to 0. Of course, if you multiply the denominator to both left-hand side and right-hand side, then left-hand side, that's going to be killed. Right-hand side, multiply to 0, that 2 is going to be killed. So in any case, we get this. 16x minus 4x cubed is equal to 0. And then, well, I cannot think straight if I see negative sign in front of the leading term. So let me change the order by multiplying -1 to both sides. So if I factor 4x out, then I get x squared minus 16. So 4x, x plus 4, x minus 4. Oh, I divided by 4, so this should be 4. Sorry about that. So x plus 2, x minus 2. Is that right? I was talking and doing the computation and typing at the same time, so I ended up making a mistake there. But hopefully you were able to see it. Anyway, there you go. Setting the numerator equal to 0, we get this cubic equation, and thus x is either 0, which is outside the domain, no problem there. X equal to -2, again outside of the domain. X equals to +2, oh, that's it. X equal to +2, right here. So we have to have local maximum f of 2, which is log of 2 squared minus 2 to the 4th power, which is log of, 8 times 4, 32 minus 16. Yeah, okay, that's log of 16. Which is, what is log of 16? Approximately 2.77 something. That's got to be the local maximum, or the absolute maximum. Let's see. Here I have 2.8, so 2.77 something, that sounds about right. That's how you do it. Draw the graph first, and then you're looking for this one here, E, and this one somewhere here. And endpoint is easy. Just plug in and run your calculator. And as for the other one here, horizontal tangent, well, you have to do some calculus. Take the derivative and set it equal to 0. Whenever you have log function, don't be intimidated. That'll make your computation simpler. Because whatever inside goes to denominator, and then you have numerator by the chain rule, and set it equal to 0, then denominator just goes away. So we have much simpler equation to work with. It's just a cubic equation that can be easily factored. You get x equal to 0, -2, or +2. But look at the graph here. You're looking for x equals to 2. Here's the answer key. Taking the derivative, and then I factored directly here. But it is okay to take the numerator equal to 0 and then factor from there. Either way. Graph, okay. That's a part of the graph. Oh, x equal to 0 is undefined here. Oh yeah, this is log, so log of 0 is undefined. Some more problem? Well, you can do something similarly. You can do this similar thing. Let's see, do we have enough time? Maybe not, so let me just show you the graph. And this part of the graph, and you can clearly see plug in 0, and 2 will not give you anything. And take the derivative, set it equal to 0 if you do it right, and you're going to get the right answer. But looks like this computation is going to be out of 1325 range. You have transcendental equation there. So never mind about this. I should have de-emphasized first. Okay. See you soon.